Well, boys, today we will start a new topic in calculus, that is tangent and normals. Tangent and normals. Boys, before starting this topic, we have to first define what the actually word tangent stands for. Actually, in common use, we always know that a line which touches a curve, that line is called a tangent in common use. But this is not the actual definition of tangent. You can understand that a line touches a curve, then it is called a tangent. But if you define the definition of tangent in this manner, you will be awarded no credit. So then what will be the actual definition of tangent? The word tangent is defined as a line, a secant, which cuts a curve at 2 points, and these 2 points coincides. Means if a line cuts a curve at 2 coincident points, then in that case we call this line, this transversal becomes a tangent to the curve. Here it is the case of limiting form. Say this one is a point P, this one is a point Q, and PQ is a transversal. This transversal cuts a curve, say y is equal to fx, at 2 points. Here the first point is P, second point is Q. Now if the point Q tends to P, on the curve, if Q tends to P, then in that case, the limiting form of Q is here just after P. That is Q tends to P. This is the actual meaning. And then in that case, suppose the second position of Q is here, then the position of second will be like this. If Q is here, then the position of second is like this. As soon as this Q tends to P, then in that case, this second PQ, it becomes tangent to the curve. So this is the actual definition of tangent. A tangent is a line which cuts a curve at 2 coincident points. At 2 points, and these 2 points are coincident, means they are in limiting form. Q tends to P. Now, here we will try to define a relation between geometry and calculus. Actually, calculus is invented from geometry. Geometry is the fundamental base of this calculus, this branch, calculus. Now, how this defines our tangent here in calculus as well as in geometry, we will discuss. You see, this is, say, the graph of a curve y is equal to fx. Say this is the graph, and this is your graph y is equal to fx. Say, now suppose there is a line which cuts this curve at 2 points. One is P and another one is Q, PQ. Now, here this line PQ makes an angle alpha with positive direction of x-axis. Now, if it makes an angle alpha with positive direction of x-axis, this one is x-axis and this one is y-axis, this one is origin, say, then in that case, the slope of this line, that is m1, is equal to tan alpha. You can easily understood with the help of class 11. Now m1 is equal to tan alpha, and alpha is the angle made by this transversal with positive direction of x-axis. Suppose this P and Q are the two neighborhood points. Neighborhood points means they are nearer to each other. So in that case, suppose the coordinates of P is x comma y and the coordinates of Q is x plus delta x, comma, y plus delta y. Whereas this delta x and delta y we have assumed as this small change in x, that is called delta x, and a small change in y, that is called delta y. And we write it, this one is delta, symbol for delta, and then x, delta x, this stands for a small change in x. It means that we have coordinates of point P as x comma y. Say if you drop a perpendicular, say here, from here to here, say PM is the perpendicular, then this OM is x and this MP is y. Now we have to change slight, and suppose this one is the perpendicular, QN is a perpendicular from Q on x-axis. Now if we increase x by mn, this length is delta x, say this length, a slight change in length of x. And similarly, if we change slight this y, here in figure it is not visible, but if we draw the exact figure, and then in that case we can explain that y is also small and this length is delta y. Say this length, delta y. So if there is a small change in x as well as a small change in y, then in that case we have this length is y, this length is y, and this one becomes delta y, so that this whole length becomes y plus delta y. So you can understand it that a small increase in x, that is x plus delta x, a small increase in y, that is y plus delta y, it gives us the coordinates of point Q, that is x plus delta x and y plus delta y. Here the coordinates of P is x comma y. P and Q are the two neighborhood points on this curve. Now suppose this point Q tends to P, then in that case if Q tends to P, then the shape of this QP second will become like this. This one will be the shape of this second PQ, like this. This becomes the shape and it becomes tangent to the curve. Suppose this second makes an angle theta with positive direction of x-axis. Now as Q tends to P on the curve, this alpha will tend to theta because the shape of this curve is like this. Now as Q tends to P, its shape becomes like this. Then in that case this alpha tends to theta. Alpha will tend to theta. Now what will be the impact on delta x as well as on delta y? You see here, as soon as suppose Q is here, then in that case if we drop a perpendicular, the shape of the second is like this. Now this one is your y plus delta y. Now this delta x, again Q is here, this one is the length y plus delta y. If Q is here, this one is the length y plus delta y. What do you observe? This whole length is delta x. As soon as this Q tends towards P, this N point try to approaches to M, this point M, then in that case delta x tends to 0. Then delta x tends to 0 and accordingly delta y will tend to 0. First impact on delta x. Why? Because y is function of x. We have assumed y is function of x means x is independent and y depends on x. So first impact on delta x and then impact on delta y. So delta x will tend to 0. So this thing we have seen that as Q tends to P, this alpha tends to theta as well as this delta x tends to 0. Now what about slope of PQ? Slope of PQ, if we observe here, there are 2 points P and Q. So y2 minus y1 by x2 minus x1, that is the slope. So you can calculate it will be delta y by delta x. y2, this y plus delta y minus y. So y cancels out. So it becomes delta y by delta x, slope of PQ. But slope of PQ is what? It is tan alpha. So tan alpha we have assumed is equal to delta y by delta x. Now as we take the limit, that limit q tends to p on both sides, q tend to p tan alpha. Then here also limit q tends to p delta y by delta x we should have. Now what impact on alpha? As q tends to p, alpha tends to theta. So we can replace this limit by limit alpha tends to theta tan theta is equal to limit. What will happen on q tends to p on delta x? That is delta x tends to 0. Here delta y by delta x. Now this alpha tends to theta, sorry, here we should write tan alpha. Now if alpha tends to theta, this tan alpha becomes tan theta. So what happens? This tan theta is equal to limit delta x tends to 0, delta y by delta x. This is the value of tan theta. And what is tan theta? We have already defined that slope of tangent will be tan theta. Now let us define this limit. Limit delta x tends to 0, delta y by delta x. What it stands for? So for that we have to omit this part. Now you see here we have P and Q lies on the curve. P and Q lies on the curve. On the curve. So curve y is equal to fx. So here for P, x and y must satisfy the coordinates. So one equation which we have is y is equal to fx, and the second equation, the coordinates of q will also satisfy this equation. So what happens? Y plus delta y is equal to fx plus delta x. Now we can remove this y to right hand side. So what happens? Delta y is equal to fx plus delta x and then minus y. The value of y is nothing but fx. So now delta y is equal to fx plus delta x minus fx. Now try to put this value of delta y here. So what you will observe? This is equal to limit delta x tends to 0, that is fx plus delta x minus fx by delta x. Now this limit you have learned in class 11, that instead of delta x if you take h, say, so what happens? Limit h tending to 0, it becomes limit h tending to 0 tan theta is equal to limit h tending to 0 fx plus h minus fx divided by h. And you know, this is nothing but first principle definition of derivative. If y is equal to fx, then its first principle definition, that is dy by dx, is this one. You have learned in class 11. So what is tan theta? Tan theta is equal nothing but it is dy by dx. dy by dx for the curve y is equal to fx. And theta is the inclination of tangent with x-axis. Now this inclination, if we take tan theta, then in that case this represents the slope of tangent, and the slope of tangent is nothing but dy by dx. And boys, this is the geometrical meaning of derivative, which may be asked in your examination, that define derivative geometrically. So in geometry, we define dy by dx as the slope of tangent to the curve. Slope of tangent to the curve y is equal to fx at any point p bracket में xy. In the bracket you should write xy. So dy by dx is nothing but slope of tangent to the curve. Remember, boys, in case of writing this, the meaning of dy by dx, some students may write wrongly as it is slope of curve. Remember, there is no slope of curve, nothing. This word is ambiguous. Slope of curve, slope of tangent to the curve. This is the actual meaning of dy by dx. And now we will try to solve problems based on this tangent and normal. So we have defined tangent, and now we can define normal. Remember, there is a tangent. Say this one is the tangent, a line, and tangent at point P, say x comma y. This is the tangent. Its slope m is nothing but dy by dx if the equation of curve is y is equal to fx. This is the equation of curve. So y is equal to fx is the equation of curve. Dy by dx is its slope of tangent to the curve at any point pxy. The line which is perpendicular to the tangent at the point of tangency, that line is called normal to the curve. This one is tangent. Remember it. This one is tangent and this one is normal. So a normal is a line which is perpendicular to the tangent at the point of tangency. We have infinite number of lines which are perpendicular to this tangent. This line, this line, this line, this line. So many lines are there. But with that line which is perpendicular to the point of tangency is called the normal to the curve. Now, one more thing is here. If slope of tangent is dy by dx, that is m, then slope of normal, since it is perpendicular, it has slope is equal to minus 1 by m. Because for two perpendicular lines, if the m1 into m2 is equal to minus 1, they are perpendicular. So, for this line, this normal, we have m into minus 1 by m, it becomes minus 1. So, slope of normal is negative of reciprocal of the slope of tangent. Now, this is the slope defined for tangent as well as normal to a curve y is equal to fx at any point. Now let us define the equation of tangent as well as the equation of normal. Boys, you know the equation of a line passing through a point x1, y1 having slope m. You know it in class 11, if a line passes through a point x1, y1 and it has slope m, its equation is y minus y1 is equal to m into x minus x1. Suppose we have a curve, any curve we have. Now there is a point, say x1, y1. On this point, if you want to write the tangent, equation of tangent, say this is the equation of curve y is equal to fx, then try to find dy by dx. This dy by dx will represent the slope of all the tangents to the curve at any point. Now for x1, y1, we should have the value of dy by dx at x1, y1. So if you find the value of dy by dx at x1, y1, you will get the slope of tangent to this curve at the point x1, y1. So this works as the value of m. And the point is known to you because this x1, y1 must satisfy the equation of the curve as well as the tangent. So what happens? How to write the equation? Therefore, equation of tangent, we can write as y minus y1 is by x minus x1. We should take this one as denominator and this is equal to m, that is dy by dx at x1, y1. dy by dx at x1, y1. So this will be your equation of tangent. This is the first part. And what about the equation of normal? The slope of normal means a line which is perpendicular on tangent at the point of tangency. So its slope will be minus 1 by m. So minus 1 by dy by dx. You can write it as dx by dy. So what happens? The slope of equation of normal that is y minus y1 by x minus x1 is equal to minus dx by dy at x1, y1. Here. So this is number 2. This one is the equation of normal. Dx by dy, or some students may write minus 1 by dy by dx at x1, y1. Both have same meaning. So this is your way to write the equation of tangent as well as the equation of normal. Let us start with a simple problem, that write the equation of take a problem on it. Write the equation of tangent and normal to x square plus y square is equal to 25 at minus 3 comma 4. Boys, you know this is the equation of a circle, and at this circle we have a point minus 3 comma 4. If you put this value will satisfy this equation. This condition is compulsory. Now we will try to write the equation of tangent as well as normal to this curve at this point. Now what to do? Suppose if you draw the circle here, say it is minus 3 comma 4, then you have to write the equation of tangent as well as the equation of normal. You have to write the two things. Now what to do? This point is minus 3 comma 4. So now we have to start with given curve. That is x square plus y square is equal to 25. Now you can differentiate it. You will get dy by dx is equal to minus x by y. You can easily understand that why this dy by dx is equal to this value. Therefore dy by dx at minus 3 comma 4. The value will be 3 by 4. Because in the place of x put minus 3, in the place of y put 4. So it becomes 3 by 4. Therefore equation of tangent, that is y minus 4 is equal to 3 by 4 x minus 3. And equation of normal, this works as m. For slope, and this point works as x1 y1. That's why we have taken y minus y1 is equal to m into x minus x1. And now here equation of normal, y minus 4 is equal to minus 4 by 3 into x minus 3. This is number 1, this is number 2. Boys, you can further simplify these two results, means you can cross multiply. Here you can multiply and keep all the terms in one side, so that you will get the equation in the form ax plus by plus c equals to 0. So in this way we will try to find the equation of tangent as well as equation of normal, and I hope that you will solve so many problems which are based on tangent and normal. We will try to solve few difficult problems in the next video. So thank you for this video.